among the reactions with the metal in the chemical properties of the metal, you have seen that we have discussed about the reaction of metal with simply chemicals. Okay, now continuing with the lecture, we are going to discuss about the reaction of the metal with water. Then how will the metal going to react when they are reacted with water? The metals do not react with water in the same way. Some metal is going to react with the hot water, some is going to react with the cold water, and some are going to react with the steam only. So metal is going to show different properties in reaction with water. So continuing with the lecture, the next topic is about reaction with water. Whenever a metal is going to react with water, it is going to form metal hydroxide. This is a one simplest formula you have to learn. So whenever a metal is going to react with water, it is going to form metal hydroxide. So this is a one simple basic principle you have to keep in your mind, that whenever a metal is going to react with oxygen, it will form metal oxide. Whenever a metal is going to react with water, it will definitely form metal hydroxide. Now firstly, we are seeing a reactions which is accomplished in cold water. So our first topic is about reaction with cold water. There are few metals which can show reaction only with the cold water. So among the metals which are going to show you the reaction with cold water, they are basically sodium, aluminium, like these metals. Clear? And there are few metals which is going to show reaction with the burning water, boiling water. So boiling water will be taken in case of magnesium. Magnesium is going to react with the boiling water and it is going to form the magnesium hydroxide. Now there are some metals which is going to react only when a high boiling water, it means steam is present, they will show you the product. So iron is going to react only in the presence of steam only. Clear? So reaction with cold water, second reaction with boiling water, and third one will be the reaction with steam. Third one is reaction with steam. So you have to see these three categories for differentiating the metal in their hydroxide form. So the first case is reaction with cold water. In this case, magnesium is reacting with cold water and it is going to form magnesium hydroxide. Clear? So there is only one metal which is going to react with cold water, and that is magnesium only. So here this water is a cold water, and you can see that the product form here is magnesium hydroxide. OH group is known as our hydroxide group. Now reaction with boiling water. There are some metals which are going to react only when the water is boiled. So these metals are sodium, potassium and calcium. These three metal is going to react only in the presence of boiling water. So whenever you are going to react this metal with the boiling water, let's see what the products we can obtain here. This H2O is boiling water here. Now sodium react with water, it is going to form sodium hydroxide. Whenever a potassium is going to react with water, it is going to form potassium hydroxide. Whenever calcium is going to react with water, it is definitely going to form calcium hydroxide. So you can see that in all the cases, you are obtaining the same product, that is hydroxide, hydroxide and hydroxide group. Clear? So there are few metals which is going to react only with the boiling water. Now let's move to the steam. Whenever a reaction is going to occur with the steam, there are few metals which first form their oxide, and in this case the hydrogen gas is liberated in the reaction. So examples which are showing you the reaction with the steam are aluminium and zinc. Clear? So aluminium when reacted with steam, whenever a aluminium is going to react with the steam, it is going to form Al2O3 with the liberation of hydrogen gas in the reaction. So you can see that the product aluminium hydroxide is not obtained in this reaction. Instead, you are getting aluminium oxide here. Similarly, when the reaction is accomplished in the presence of steam with the zinc, same situation is going to occur here. You will not get the product, that is zinc hydroxide. Instead of that, you will get the zinc oxide with the liberation of hydrogen gas again. So this is a exception here, that the product you are obtaining is not hydroxide in hydroxide form. Now after reaction with cold water, reaction with boiling water and the reaction with steam, there is one more exceptional term, that is about the iron. Iron is going to react with water only when the conditions are very extreme. It means when a red hot iron is going to pass through a high steam, it means the steam's upper level, then it is going to form the iron second or third oxide. In this case, it is not going to form the hydroxide. Instead, again it is forming the iron oxide here. So the reaction with iron is different in this case. If I am considering the reaction with iron, the symbol for iron is Fe. Whenever this Fe is going to react with steam, this is a steam which is of very high, you can say very high temperature steam, or very hot steam is passed through it. Whenever this steam is passed through the iron, it is going to form Fe second or third oxide. And again the liberation of hydrogen gas is going to occur in this reaction. So you can see that whenever any metal is going to react with the steam, it is not forming hydroxide, it is forming oxide and with the liberation of hydrogen gas. But there are few metals which is reacted with boiled water or cold water, you can see that the hydroxide is going to form in the reaction. So one thing you must have to remember, that whenever a metal is going to react with water, it will form hydroxide, but you have the two exceptions here. Clear? Now after reaction with oxygen and water, we are moving to the third category, that is about reaction with dilute acids. Whenever a metal is going to react with the acid, it is going to form a corresponding salt along with the liberation of the hydrogen gas. So if you are considering the dilute acids, you have to take only two acids, that is dilute HCl and dilute H2SO4. So we will do all the reactions with hydrochloric acid and sulfuric acid only. So let's proceed to the next part here. The reaction will be the reaction with dilute acids. So the simple key formula is, whenever any metal is going to react with dilute acids, and these dilute acids will be either HCl or H2SO4, you can take here. So whenever a metal is going to react with dilute acids, they are going to form metal salt along with the liberation of hydrogen gas. So this is a fundamental principle, that is the product form is always the metal salt along with the hydrogen gas. Clear? So we are starting with our first reaction. There are few metals which is going to react only in the simple condition. There are some conditions in which the metal react is going to liberate hydrogen at a very high expanding rate, and the third case will be some metals are like that, they are not going to show you any reaction with these acids. So again we are considering the different conditions for different metals. So firstly, I am assuming the conditions for sodium. If sodium is going to react with these metals, definitely a corresponding salt is formed along with the liberation of hydrogen gas. So the first reaction is reaction with sodium. The second reaction is reaction with magnesium. Third is reaction with zinc. Fourth one is reaction with iron. The fifth case is reaction with copper, that I am writing here. So our first case is reaction with sodium. In the first case of reaction is with sodium, whenever a metal is going to react with HCl or H2SO4, the salt is formed along with the liberation of the hydrogen gas, and the hydrogen gas is liberated very violently in this reaction. It means the rate of liberation of the hydrogen is very fast here. So what will be the reaction in this case? Firstly, I am reacting Na with HCl. This is dilute HCl. So it is going to form NaCl along with the liberation of hydrogen gas. So for balancing this reaction, you can put 2 here and 2 here. Clear? So this is sodium, this is hydrochloric acid, and you can see that sodium salt is formed along with the liberation of hydrogen gas. Similarly, when sodium is going to react with H2SO4, H2SO4 is sulfuric acid. So it is going to form Na2SO4 plus hydrogen gas is liberated in the reaction, and for balancing this reaction I have to substitute 2 here. So you can see that whenever a sodium is going to react with HCl or H2SO4, it is forming metal salts along with the liberation of the hydrogen gas. Similarly, when reaction with magnesium is accomplished, magnesium when reacted with HCl is going to form MgCl2 plus H2 gas is liberated in the solution. So for balancing this equation, I have to substitute 2 here. Clear? Similarly, when magnesium is going to react with sulfuric acid, it is going to form magnesium sulphate along with the liberation of hydrogen gas. So this is the reaction in case of magnesium. Now moving to the third category, reaction with zinc. Whenever a zinc is going to react with HCl, it will form ZnCl2 plus hydrogen gas is liberated in the solution. Similarly, when zinc is going to react with sulfuric acid, it is going to form zinc sulphate along with the hydrogen gas. So this is the reaction that is going to take place in case of zinc. Now moving to the iron. Iron is going to react with HCl and H2SO4. In this case, the reactivity is bit low. It reacts slowly with these metals. So the reaction with iron will be the slow process. It is not going to react very rapidly with iron. So whenever these metals are going to react with iron, Fe plus HCl, so you will get FeCl2 plus H2. Whenever a reaction is taking place with sulfuric acid, ferrous sulfate is formed along with H2. So this is the case with iron. Now, the next case is reaction with copper. Next reaction is reaction with copper. So whenever a HCl and H2SO4 is going to react with copper, the interesting thing is that it will not going to show you any reaction. So this is the exceptional case here, that whenever a copper is going to react with HCl or H2SO4, no reaction take place. Clear? So you can have seen that whenever a metal is going to react with dilute acids, it is definitely going to form metal salt along with the liberation of the hydrogen gas. So firstly, we have seen the case for sodium, then we have taken a case for magnesium, zinc and iron. So in case of the iron, the reactivity is bit low as compared to these metals. Now finally, we have seen a case of reaction with copper. So copper is not going to react with HCl and H2SO4, and you can see that no product is going to be formed here. So the question arises here, write the reactivity of different metals with dilute HCl and H2SO4. So if I have to arrange these reactivity order, so I can say that sodium is going to react with HCl with a very fast rate. After sodium, you have magnesium, aluminium, zinc, iron, and in last you can substitute copper. So this is the reactivity of different metals with dilute HCl and H2SO4, in which sodium is going to react very vigorously and copper is not showing any reaction. So this ascending descending type questions can be frequently asked in your exam. So just know the series or know the sequence that what you have to follow in case of different metals. Okay, so this is about reaction with acids. Now let's move forward to the last part of this topic, that is about the reaction with salt solution. So our last category is reaction with salt solution. So this is our fourth case, that is about the reaction with salt solution. So what we have discussed till now, firstly we have seen the reaction with oxygen, then we have seen the reaction with water, thirdly reaction with dilute HCl and H2SO4, and the last case is reaction with salt solution. So what will happen in case of reaction with salt solution? Whenever any metal is going to react with the salt solution, the more active metal is going to replace the less reactive metal. Similar things are happening. Suppose you are sitting or suppose you are studying in a class or in any class of various students. So you can see that the teacher is going to encourage or pleasure always the student who is having a high percentage in the class. So if the student is having the high percentage in the class, he or she is going to replace the other students. The student which is a bit poor or bit weak in studies, the teacher is not going to consider that student. That actually happens in every situation you can see. So the more intelligent student is always going to replace the less or weaker student. So similarly, in case of the metal, if the active metal is more reactive, then it is definitely going to replace the less reactive metal. So in case of salt solution, whenever you dip any metal in any salt solution, you will find that the more active will going to replace the less active metal. So I am considering here the case of zinc and copper sulphate. So what is the basic fundamental you have to learn here? That more active metal replace less active metal. Clear? So in this case, the more active metal is going to replace the less active metal. So this is the key principle for this reaction. So in the first case, we are considering the reaction of zinc with copper sulphate. So our first case is reaction of zinc with CuSO4. So the reaction will be zinc plus CuSO4. Now what will happen whenever you dip a strip of zinc in a copper sulphate solution? You know that the copper sulphate solution is blue in color. So if you dip a zinc strip in a copper sulphate solution, the zinc strip is getting coated with copper and the copper sulphate solution will become colorless here. So whenever a reaction is accomplished, you can see that the product form is ZnSO4 plus Cu. This will be the reaction here. So you can see that zinc is coated with copper in this reaction and the solution become colorless now. The blue colored solution will become colorless. Clear? So this is the reaction which is going to take place here. First thing is the zinc is going to replace copper. It means the zinc strip is getting coated with copper and the blue color of the copper sulphate is going to be colorless now. Now similarly, I am considering the just opposite reaction here. The second reaction we are taking into consideration. Firstly, we have seen that we are reacting zinc with CuSO4. Now I am reacting Cu with ZnSO4. Clear? So let's see the difference what I am doing here. Reaction of copper with ZnSO4. So whenever a copper is going to react with zinc sulphate, no reaction is going to take place here. So what will happen in this case? Whenever a copper is going to react with zinc sulphate, you can see that no reaction take place. So can you tell me what will be the basic difference between these two reactions? Just think a minute and observe that whenever a zinc is going to react with copper sulphate, the reaction is accomplished here. But whenever a copper is going to react with zinc sulphate, there is no reaction take place. Now the important point is why it is happening so. The basic principle of these reactions is that whenever a more active metal is going to react with less active metal, then only the reaction is going to be accompanied here. So you can see that in case of zinc and copper, copper is less reactive than zinc. That's why copper is not able to replace zinc in this salt solution and therefore the reaction is not going to take place here. But in this case, you can see that as zinc is more reactive, zinc is taking the place of copper. So it is replacing copper in this part and in this reaction, it is not able to replace the copper. So one conclusion you can draw on from here that copper being less reactive, not able to replace zinc. So copper is less reactive metal and it is not able to replace zinc. So this is the principle we have applied in this reaction. So this is our last case that about the reaction of metal with salt solution. So whenever a metal is going to react with salt solution, the more active is going to replace the less active metal. So in the chemical reactions of the metal, you have seen the reaction with oxygen, water, dilute acids and salt solution. So this is all about the chemical reactions of the metal. So this lecture is all over for today. We will deal with many more terms in our next lecture. Thank you so much and have a wonderful day.